So verification is if does the solution satisfy the ordinary differential equation. So you may think this is brutal. Yes, it is brutal. So here it is, y equals 1 minus e to the 2x minus 8. And the denominator is basically that same thing, but with a plus. And now what we have to do is that we have to compute the derivative. So we differentiate this with respect to x. In differentiating, so let me put here as a bubble thought that u over v, the derivative of this quotient, would have a denominator v squared, and this becomes u prime v minus u v prime. That's the so-called quotient rule, right? The quotient rule. So we have a quotient. We have an expression. We have an expression here. One numerator, 1 minus exponential. Denominator, 1 plus exponential. We differentiate using this quotient rule. So when we take the derivative, we're going to have a denominator in square. That would be this 1 plus e to the 2x minus 8. And the numerator is going to be something that looks like this. Right? So we have something multiplying another factor minus the product of two other factors. Okay, so let's see what this numerator looks like. Let me make this more spacious here. Okay, so that numerator would be the derivative of 1 minus exponential, which would be 2 times e to the 2x minus 8. And the next factor is exactly the same denominator, 1 plus e to the 2x minus 8. The next one would be, bless you, 2x minus 8. And this here, that factor would be the derivative of the denominator, which would be 2 times e to the 2x minus 8. Right? So that looks, it's looking like this. So I have a square of the denominator. I'm not going to write it quite yet. We can cross multiply this. This will look 2 e to the 2x minus 8 plus 2 e to the 2x minus 8 times e to the 2x minus 8. That becomes e to the 4x minus 16. We have to be careful. There is a minus there coming up, so maybe I can do that in another color here on top. If we cross multiply, this would be 2 e to the 2x minus 8. That multiplied by the other one would be minus 2 e to the 4x minus 16. But when we apply this negative sign right here, that's going to make the first one negative and the second one positive. So the first one becomes negative 2 e to the 2x minus 8, and the second one becomes positive 2 e to the 4x minus 16. And I keep indicating the denominator, so square. I'm going to do that at the very end, right? The good thing is that do you identify certain terms that does it become easier or harder and horrible? Can we simplify? Is there anything that simplifies this? Thankfully, there is a cancellation here. This 2 e to the 2x minus 8 cancels with the very first term, that numerator, right? And that will make things a little more bearable, right? So now the numerator becomes 4 e to the 4x minus 16, and then the denominator stays there as a square. And that was 1 plus e to the 2x minus 8. All these steps were to compute the derivative of y with respect to x. Now, does this conclude the verification? Oh no. What? Why not? Because we need to verify that that first derivative is equal to that product. By the way, that product looks like a perfect square or something. There is like a name for this kind of thing, right? That product, y minus 1 times quantity y plus 1, can be written as y squared minus 1 squared, y squared minus 1, basically, right? But that verification means that we're able to write that derivative in that form. Oh, goody. So far, I don't see it. Yeah, that's okay. You don't see it. But let's put this on hold, and let's work with this right-hand side. So we just computed. Basically, we want to verify that one thing is equal to another thing. We just have an expression for derivative of y with respect to x. Let's go ahead and work with the product y minus 1 times y plus 1, and let's see what that is equal to. And hopefully, that will be equal to our first calculation, right? So sometimes you read things in books and they say, yeah, and now you factor this, factor that, and para, you know, like, yeah, it looks very elegant, but things don't really work like that in practice. So let's now work with, let's put this on hold here. I don't know, I'm going to put a triangle there, meaning that we're coming back to this triangle in just a minute. So let's work with y minus 1. What will be y minus 1? Remember, y is a solution. We're subtracting 1. The solution has 1 plus e to the 2x minus 8. Right? And in the numerator one, we have the difference. So 1 minus e to the 2x minus 8. We subtract 1. This becomes 1 minus this minus so let's see, here we have 1 minus e 2x minus 8. This becomes minus 1 minus e to the 2x minus 8, and this is, the denominator stays exactly the same. So there are terms that cancel here. This 1 and negative 1, they cancel each other, and then we add up. Just 1 second. Right, so we add up those terms. The numerator is minus 2 e to the 2x minus 8. The denominator stays exactly the same. This is what we have for y minus 1, okay? Let's now compute y plus 1. Y plus 1 would be we add 1 to y, and so this becomes this 1 minus e to the 2x minus 8 plus 1 plus e to the 2x minus 8. Now the exponentials are going to cancel each other, right? So now this exponential cancels with that, and this becomes 2 over 1 plus this. This would be y plus 1. So we have an expression for y minus 1. We have an expression for y plus 1. Let's now multiply them together. Okay, so we have y minus 1 times y plus 1. So here is y plus 1. I'm going to write that first. Y minus 1 is negative 2 Now when we multiply these two terms together, the numerator becomes negative 4 times the exponential, and the denominator becomes that same quantity squared, right? So we multiply those two together, then this gives us the square of 1 plus the exponential, and the numerator becomes minus 4 times the exponential. This, let's go back. So this is y minus 1, quantity y minus 1 multiplied by quantity y plus 1, right? It looks like a fraction. It involves exponentials. And we had obtained previously that the derivative that derivative is, so do they match or do they don't match? What was it? You think they match?
Dr. C, can you hear me?
Yeah, I can hear you.
I think we didn't carry a negative when we took a derivative earlier.
Yeah, right? Because right now they don't match. So, and they don't match by a negative. So we have a 4 exponential divided by a square, and um, so the only discrepancy is a negative, and I think that's exactly right. Something was leave checking this right.
Yeah, taking
Yeah.
the derivative of the numerator.
The derivative of the numerator should have a negative, right? So thank you. So the derivative of this numerator here, there should be a negative. It's 2 times that, but there was this negative, right? So then there will be this here. And I think that's what causes, right? Let's see, with a negative there, negative there changes this calculation. I can see. Negative times 1, and negative times the other one, so this would be minus 2. And then this here becomes minus, also minus 2. Right? So now that term cancels. The terms that cancel are going to be this term and the last term. And the terms that are left are minus 2 e to the 2x minus 8. That minus 2 is repeated twice. And so this becomes minus 4 e to the 4x minus 16. That was it. Yeah. So there was a problem with the derivative of the numerator, that this derivative of y really is negative 4 times that exponential, and that is indeed what we verify. That's indeed what we verified here, right? The previous page? because those are the ones that, yes, the ones that survive are, yeah. Yes, yeah. Let me change that. So this would be the exponential of 4x minus 16 is precisely what cancels now. Yes, yeah. So that's what you're pointing here. So this, what survives here is negative 4 e to the 2x minus 8. Okay? So, um, so this verifies that that solution satisfies the differential equation, and also that by plugging in the initial value, the initial condition is also satisfied. So you have to verify basically two things. The other case that we didn't work here is the situation in which y is bigger than 1. In such case, the absolute value has a different expression, and then some of these calculations, you also have to do a verification there. But I'm going to leave that to you. I just did half of this.